All right, so in this video, we're going to talk about writing the equation of a polynomial function. And what I'm about to do, you've probably already seen in Math 3, so this is just a good reminder. I'm only going to do one example. Okay, so over here, you already see standard form, right? Again, a sub n is your leading coefficient, n is your degree. A sub 0 is just a constant. That's going to be relevant later when we cover the rational root theorem. And you may not know intercept form, right? Intercept form is basically my standard form in factored form, right? So another way of naming this is called factored form. And again, a sub n is your leading coefficient, x of n are your zeros, and p of n, right, whatever that multiplicity or whatever that exponent is. So far I talked about multiplicities, right, how many times a zero occurs. You will see that in the context of graphing. All right, so the way to go from intercept to standard, right, is you FOIL. And the way you go from standard to intercept, right, you factor. Okay, so you're going to have to be comfortable with both. But in this particular video, we're going to write our function in intercept form, and then we're going to FOIL it. So we're going to go from 2 to 1. All right, so you may have heard this theorem before. It looks very, very intimidating, but it's not that bad. It says given f is a polynomial, and a and b are rational such that root b is irrational. So if you forgot what an irrational number is, right? Something that you cannot take the square root in your head. These are all irrational numbers, okay? So if a plus root b is a 0, that means a minus root b is a 0. Okay, so vice versa, right? If I say if a minus root b is a 0, a plus b is also a 0. So these guys always come in pairs, okay? All right, so as I mentioned, I'm just going to do one example, and hopefully you understand this one example and able to apply it to your homework. So it says write a polynomial function that has the given zeros, assume that the leading coefficient is 1. Okay, so what we're going to do right now is identify the 0, right? One of the zeros is 3, and over here I have an irrational expression. Okay, so when I have 2 plus root 5, immediately I know that 2 minus root 5 is also a 0. So I didn't forget to write this, I just want you to apply the concept. Now in your textbook, when you see the problems in your homework, they're going to give you 2 plus root 5, 2 minus root 5. Okay, so on a quiz or test, I might just give you one of these, and then you have to deduce that the other is also a 0. Okay, so do I write, positive 3 minus 3? No. It only applies to irrational expressions. Okay, so a plus root b, a minus root b. So don't write positive 3 minus 3. All right, so over here, we already know that the degree of our function is going to be 3, right? Because x times x will be x cubed. So just, it's nice to know the big picture at the end when we FOIL it. All right, so how do I start? Well, I'm going to start by writing my factored form, right, or intercept form, x minus 3 times x minus. Now, when you put this guy in the minus sign, after the minus sign, make sure you put, in fact, maybe I'm just going to put parentheses. I'm going to put brackets over here. Okay, I'm going to put parentheses 2 plus root 5. Close it with a bracket. And x minus parentheses 2 minus root 5. Okay, so you really have to be careful with that minus sign, or you're going to have some trouble. Okay, so remember we said the a sub 1, the leading coefficient, is assumed just to be 1, so that makes things a little bit nice. So on this next line, what you want to do, right, is just kind of distribute that minus sign, and I'm going to do that now. So I have x minus 2 minus root 5, and I have x minus 2 plus root 5. Okay, so at this point, right, you could probably figure out what the answer is just by multiplying a binomial times a trinomial times a trinomial. But on this particular line, okay, this is going to be a key step right here. And actually, I'm going to erase this. And I'm going to put bracket signs again. All right, so I'm going to just put bracket over here. Okay, so over here, instead of multiplying a trinomial times a trinomial, right, what you want to see is that I have an x minus 2 over here, and I also have an x minus 2 over here, right? I have a root 5 over here, and I have a root 5 over here. And so this is just the pattern of a minus b times a plus b, right? And what is a minus b times a plus b? Hopefully you memorize that, right? That's just your sum and difference pattern. That's a squared minus b squared. Okay, so what I'm going to do on the next line is I'm going to group, my x minus 2, right? And I know it's just a squared minus b squared, right? So if that's my a value, it's x minus 2 squared minus root 5 squared. Okay, so that's the key line right here. Hopefully you see that this is a pattern of a minus b, right, times a plus b. And if you're able to see that, right, the result of a minus b times a plus b is just a squared minus b squared. So that's going to make our work a lot less tedious, even though it is tedious to begin with. Let's FOIL this. Over here, you're going to get x squared minus 4x plus 4 minus root 5 squared is just minus 5. Okay, so you can, I'm not going to, well, I guess I will write an extra line. X squared minus 4x minus 1. And now this is less intimidating, right? What you have is a binomial times a trinomial. And then make sure to FOIL. Okay, so distribute the x. You're going to get x cubed minus 4x squared minus x. And underneath here, I'm going to write minus 3x squared when I distribute the negative 3. Positive 12x and positive 3. Okay, so add that together and you will have your polynomial function. So f of x is equal to x cubed minus 7x squared positive 11x plus 3. So this is the standard form, and that's the equation that they want you to write it in. Okay, and then of course this was your when you wrote it here in the beginning, right? This is factored form, right? Or intercept, I think was the word that I used. Factor or intercept works. Okay, so the key line right here is to go from here to here. If you're able to see that, you're able to simplify your work quite a bit.